The next chapter is naive Bayes classifier, and we're going to look at um, what's in your textbook, like the OR code in the textbook, but not all of it. And we'll also look at how to run naive Bayes using our caret library. So first, let's set the default folder path. Okay, and then let's set up some libraries. So these are the libraries we need. Okay, the tidyverse will give you ggplot, and you need this one for naive Bayes, and caret will be using caret, and to run naive Bayes in caret we need that one, and then we need gains for lift charts. Okay, so go ahead and run those. Next we will read the data file. We're going to use the flight delays data file. So delays.df is read.csv, and within quotation mark we have flight delays.csv. That's the name of the file. Okay, so now we have the file read in. Let's examine the data set. We have 13 columns. Okay, so this is the scheduled departure time, carrier, the actual departure time, destination, distance, flight date, flight number, and so on, right? And then the last column 13, is the flight status, whether it arrived on time or not. Okay, here we can tell that tail number is not going to be not going to have any predictive value with respect to whether flight is on time or not. And another one is distance. Okay, and the flight number is again something that is not going to have any predictive value. So what we are going to do is let's first do an str and examine the column information, and you see there are some character variables, right, and then some integer variables. So here we're going to first take a look at the day of the week and departure time. Okay, we're going to convert those two into factors. Okay, and remember, naive Bayes works well when you have limited number of values for each column. Okay, if you have lots of different values in a column, like if it is a continuous variable, then that's going to bog down the computation. It's going to have a lot of computation to do. So it's a good idea to bin them into class intervals. Okay, so which is what we're going to do with respect to the scheduled departure time. Okay, we will convert the two variables into factors, and I'm following the same sequence like in the textbook, so you can see the code from there as well. So we have delays.df, and we have day of week. Okay, and the reason why we are converting only a couple of variables to factors, because we are going to use only a couple of these variables in the model. So there are many variables which we will not be using, as we will see in just a minute. So we're going to change this to a factor, delays.df, day week. Okay, and then the departure time. Delays.df departure time as factor delays.df departure time, right? So let's run these two lines of code. Okay, so now if you run this str again, you'll see that those two are changed to factor. All right. Next, we're going to bin, okay, the scheduled departure time. So this way we'll get to do an example of binning a variable, which we did not bin departure time. We could have done that too, but we just converted that into a factor. So and here we're going to convert the departure time into binned values, right? And and there are a couple of ways in which we can do this. And okay, let's look at the values. So here we have the departure time. Well, this is the one, the scheduled departure time. So we have 4-digit number, the last 2 digits are the minutes, and the digits before that are the hours. So 14:55 is 2:55. Then 9:30 would be 9:30. Okay, so if we divide this by 100, then we will have the hour, okay, and then dot the minutes. Okay, so if you want to bin them to hours, then we can say, all right, I'm going to divide by 100 and then drop the minutes part, so that way it'll get binned into the hours. So we can do delays.df and then take CRS departure time and you divide by 100, right? So if you do that, then you get all these bunch of numbers with the hour part to the left of the decimal point and the minute part to the right of the decimal point. Now, if we use, okay, so there is this function called floor, okay, and if we use floor around that divided value, so that means this will convert every number to the largest whole number, that doesn't exceed the actual value. So for example, if for 7.30, floor will be 7, right? For 15.25, floor will be 15. For 9.00, the floor will be 9. So let's run that. Okay, so then we get the largest integer value not exceeding the actual value. So that's the this is how we have rounded or we have binned the values. Okay, and before we actually put that into a column, right? What we need to do is we need to change that to a factor as well. So this is what we're going to convert the CRS departure time to. Okay, so now you see these are the levels. So all of these values are now summarized into these possible values. So 6 would be from 6 to 7, right? 7 would be 7 to 8 and so on. And we could do this in a different way as well, and that would be by using bin code. We did this several chapters back. So in bin code, we again specify what is the variable we want to bin. Okay, so that is the variable we want to bin. Okay. Um, well, actually, you want to divide by 100. Remember, we need to convert it into a value that has the hour part to the left of the decimal and the minute part to the right. So that, and then we give um, a list for the bin breaks. Okay. Okay. So we give that as a list. So over the period of time, so you, like for example, 0 at the start of midnight, starting the first hour of the day, and 23 being the last hour of the day, right? So we can say 0 through 23. Okay. And the breaks that are not needed will not be used. Okay. So if you did that, then there is one more thing you have to specify, whether you want the right side to be open or close. Okay, when you say false, then right side will be open. So which means that the right side value will not be included. Okay, like if it is 67, the false would say the actual the whole value 7 will not be included. 7 will be included in the next break. Okay, so now you see the same thing is done with uh, pin code, but there is one difference, and that is the the this way. Okay, by dividing and computing the floor, each value is converted into the lower limit of that bin, whereas bin code assigns the upper limit of the bin. For example, the very first value is 15, and when you use the first method, it is 14. But that doesn't really matter because these are just numbers indicating which bin it is. Okay? The value itself doesn't have any significance, but it is the bin in which a variable is classified. That's what matters. Okay? So we can use either one of them, and I will just use um, what is in your textbook. So that will be delays.df CRS departure time. Okay. Now that is set to the binned value. So right now the CRS are the scheduled departure times. Now we run this code. Okay. So now you go back and you see this CRS departure times are now binned.